Maybe you've heard the term CPU, but what exactly does it mean? You're wanting to build a PC for the first time, you get to the CPU part and there's so many different numbers, letters, specs that don't make any sense to you. Well, in this video, I'm gonna explain everything to you about CPUs, what do they mean, how to choose the right one, how to not make any mistakes, and you can even enter into a conversation with some of your more geeky friends after this video.
What is that?
Let's go. Licensing Windows is cheap and easy with whokeys.com, and if you use the code TN20 you get an extra discount. Complete the purchase, copy the key and paste it to the activation settings. And you're all done. Also check out their Microsoft Office 19 license and use the same code TN20 for the extra discount. Check out whokeys.com in the video description below. Now, one of the main things you see online are different manufacturers of CPUs. There are mainly two CPU manufacturers. We've got AMD and we have got Intel, and that's the ones you should remember just for now. Apple is making their own CPUs technically, there's Nvidia that makes their own CPUs technically, and some other ones, but for desktop and laptop CPUs, we're mainly seeing these two competing each other. One of the first things you see when looking for a CPU, you realize that there are different namings of the CPU. This one here is i9, this one here is Ryzen 9, there's i5s, i7, i3s. What do these actually mean? Intel and AMD, both of them have namings for their different CPU SKUs, or meaning different levels of product, lower ones and higher ones. The higher the number, the better it is. Ryzen 3, Ryzen 5, Ryzen 7 and Ryzen 9. The same in here, Intel Core i3, i5, i7 and i9. The higher the number, the better it is in the generation. But that's not all. We have other bits in the end of the name of these CPUs. Let's take this for example. We have an i9 14900K. The i9, you know what that means. The i9 references that this CPU is going to be higher than, i7. When this becomes an i7, it's not 14900K anymore, it is actually 14700K. Then we have i5, which would be 14600K, and an i3 something else. But within the i5 territory, you can have different CPUs. You can have 14600K, you can have 14500, you can have 14600, you can have 14400. All of these are i5s, but how do you know which one is better? What we need to do is actually separate the naming to a few different areas. Firstly, we're going to look at the back here, which is K. Then we're looking at the 3 digits in here, 1, 2, 3. And then we're looking at whatever is left in the front here, because it might be 2 digits or it might be actually 1. So we're looking at this bit here as well. Firstly, we'll start from the front here. This 14 means the generation. It might be below 10 as well. So if you have 900K, that means that it's the 9th generation. The higher the number, the later the generation. We'll explain that in a minute. Then we have these 3 numbers in the end here, and these are basically different SKUs within, or different models within the i5, i9, i7 models. You can have 900K, you can have i7 or i9 800. Basically, the higher the numbers, the better it is, or the more you get. You can get 900, you can get 980 sometimes even, and so on. The higher the number, the better it is. Then we have the last bit here, which is the K. You might have seen that there are a lot more different letters than just K. There are options that have nothing, and we'll take this as nothing. When there's no letters in the end of the naming, like we have over here, this is i5 12400. This means that this processor is not overclockable, and it only runs in the provided power limits of the CPU, which often is 65 watts on the base power and then some kind of a turbo power. But for now, you need to remember that when there's no letters in the end of the CPU, it's basically the base configuration of the CPU. Then we have an F. When there's an F on the CPU, this means no iGPU. The processor doesn't have any integrated graphics, and when wanting any video output, you need to have a dedicated graphics card. Next, we have a K CPU, which you have in the end there, that means that the processor is overclockable. Maybe you don't want to do manual overclocking. Having a K CPU is still better than a non-K CPU because your motherboard can do some of the overclocking on your behalf and you get more performance out of the CPU even if you don't do manual overclocking, if that makes sense. Then we have something called KS. And that KS never appears separately. You can never have an S CPU. You have a KS, and the KS is all the time the i9 something something KS, because the KS means it is a binned version of the CPU. Think of this as the tuned or limited edition of a CPU that is binned to the absolute maximum performance. Like you have something in cars, you have a limited edition of a certain car, Lamborghini Huracan, for example, a limited edition, something performance pack. That's what you have, a KS. It often has a little bit more performance or a little bit better silicon quality, which means you can overclock it even better than some of the non-KS versions. They're often very, very expensive, and for most people, you probably should forget about them because they provide marginal performance over the K version if you're 14900K versus 14900KS. Then we also have a T version, which means that this will be a lower power version. It is actually below the base, and it goes... The T versions often go into some of the special PCs like a mini PC or a pre-built PC that has a very set power limits and you don't want to do anything. Everything's very set and locked down. That is a T. It's actually a little bit below the base version because the base version can go higher than the T. Now you might have noticed that there are actually something else called an X and XE as well. And this, what we're talking about here, is Intel. We're not talking about AMD right now. If you want to see AMD as well, leave me a comment in the comment section below so I know you'd like to see that from AMD as well. A lot of these things can also apply to AMD, so even when watching this one, you might actually figure out some of the AMD versions already by just sticking till the end of the video. There are actually an X and XE CPUs as well, which are Xeon CPUs, something like this or something like that. They also mean the same things, that they are overclockable. Now, that is not all, because Intel has recently launched a new separate SKU of their processors, which is called Core Ultra, and this will be Intel. There is no AMD Core Ultra. And you might be thinking that the Core Ultra is something that goes even top, something even higher, because Ultra surely is more than a non-Ultra. Well, that's where you will be mistaken, because Core Ultra means efficiency. And these Core Ultra chips you will see in systems like this. This laptop here is the ZenBook 14 OLED, and this one runs the Core Ultra 7 155H. We'll talk about that in a minute. And that means that you have the best performance and the most efficient performance as well. You'll have the longest battery life, and that's what we can see with the Core Ultra CPUs. A lot better battery life than previous generation. If we take tips from the previous page, you already know that there are Core Ultra 3, 5, 7, and 9. These work exactly the same. We call it U right now because that means Ultra. L is before the T. And that works exactly the same as on the previous model here. i3, i5, i7, i9. What makes this Ultra different is that this naming scheme now starts with a little bit of different lettering. For example, the CPU inside there is in Core Ultra 7 155H. And here, that bit here, the first number means the generation of the CPU. Here we see other two numbers, not three numbers anymore. That means the higher the number, the better this is, because you have Core Ultra 9, for example, that can be 185H, which this laptop, you can also get this in a configuration of Core Ultra 9, and then you have 185. So these two mean the higher, the better, basically this means, but you can never get a Ultra 7 185H. So sometimes these numbers will reflect to the Ultra 9, Ultra 7. And then we have an H in the end of the numbers. So what does the H mean? And when it gets to laptop CPUs from Intel, there is a lot more letters in the end that we have to learn. Bear in mind sometimes you can get these laptop CPUs like this Core Ultra 7 155H also in mini PCs. Some manufacturers recycle the laptop CPUs and actually bake them into some of the mini PCs so you can still use them, but they don't have screens, but they're still laptop CPUs. Now, let's learn the laptop or mobile processor letters in the end. There are a few, and they go in order like this. We have a Y, which is an ultra low power CPU, but it's not called Core Ultra. It's just an ultra low power. Then we have U, which is a little bit of a higher power. So we just name these as little arrows here. The first one only has one. A P version, which means we have just a little bit more power. Then we have 3 arrows. And as we move up in this scale here, H will mean even more power than P and U and Y. We actually start to lose the battery life. And here's how these different SKUs or namings actually tell you how much battery life can you expect. And you'll see that the actual battery life spec will also link to the naming of these CPUs. That U processors will give you better battery life than P and so on. But also the battery size matters and the power in there. There is power limits there. U and P usually have somewhere around 20-30 watts and so on. As you go higher, you can get higher and higher power limits for this, and you'll realize the laptops get bigger and thicker as this naming goes higher and higher. We've come to the H, and basically these are the 4 main ones. And the Core Ultra usually replaces this here, the P. And as you can see, even the Core Ultra will have the H in the end, which they'll take it from here. Some of this can be very high powered, but the H power limit, what I have seen from this, is a lot lower than you usually see on a 13900H, for example. Even though the Ultra, being a new generation, will actually replace roughly around somewhere here with the P Powerdraw in there. You can get the Core Ultras up to 65 watts, something like that, but I don't want to make this too complicated right now. Let's just learn these letters and what these mean with the CPUs. HK, you can already figure out what this means when you know the K from the previous letter, which means that the K means it's overclockable. So this basically means high power and overclockable. The HX though means that this is high and this is even higher power and overclockable, because the HX is basically the closest to the desktop. We'll say that this is roughly the same as a K on a desktop version. So you'll realize that if you've got something like the 13900HX versus 13900K, then you realize that these will have exactly the same core counts and thread counts, but just the HX will have slightly lower power limit because laptop can't pull as much power as on the desktop. So the HX will be the highest that you'll see on a laptop. You'll never see a HX inside a desktop CPU. Going quickly back to the Core Ultra. The Core Ultra is the first Intel release of CPUs that also has something called AI processing inside the CPU. So inside the CPU, you'll have something called an NPU, which means neural processing unit, and that is where AI processing happens there locally in your CPU. This right now doesn't give us much information what we can do with it or what this allows us to do with it, but just so you know, when more AI stuff comes out, the AI CPUs can do some of this stuff a little bit faster, and we can utilize this. When you start looking at the CPUs, the next thing you'll probably see next to the CPU is cores. What do CPU cores mean? CPU cores can be seen as little workers or brains inside the CPU. So when we see a CPU, it's very common to see 4, 6, 8 core CPUs. We'll have a 6-core CPU right now, and the more the cores you have, the more workers you have. So when you throw data at the CPU, which means all your tasks, what you're doing, whether video editing or just simple Chrome tasking or playing games or doing some rendering, these are all different tasks that these CPU cores have to figure out what to do. And you might be actually sending data from all different places to the CPU. And as you can see, the CPU goes into here. This is the CPU socket, and the CPU might take data from your SSD, from your graphics card, from all sorts of different places. And this is where it crunches crunches the data and actually makes it work and figures out what to do with it. The more cores you have, the better the CPU, because it's able to process more work at the same time. Next to the cores, you might see something called threads. And a lot of people might think that the thread, if we just look at the, zoom in right now into one of the cores, they think that the thread will just split the CPU into two and you have 2 threads per core, which means that you can just crunch data at 2 separate cores. So basically, you look at your task manager and you see logical cores in there, and you'll see that, oh, they're crunching stuff all at the same time. That is not actually entirely true. It's better to see the cores and threads as a conveyor belt. If you've got a core in there, let's just zoom into one core in here. Basically, let's see that this is a conveyor belt that moves this way. And then let's put another conveyor belt in here. Let's see that these are threads, and this is just data that the CPU is crunching, and this is just zeros and ones, and like that we have not 2, just 1, 0, 1, 0, 0. This is the worker here that does and crunches the data. You've got one thread that loads this in there. Let's say this is a Chrome in there, and this is video editing in here, and another program, for example. The CPU can actually handle and do one thing at the time. Once this thread is there, it works this out. But let's say that this thread here ends. This happens super fast, which you'll realize in a minute. Then the CPU is thinking, okay, I've got nothing to do. It's good to have another thread with another piece of work so that the CPU core will always keep working. If you don't supply work to the CPU at the same time, that's when we realize there's latencies and bugs, and sometimes your computer freezes or something like that, because the data that needs to get to the CPUs, either there's not enough cores available or not enough threads available, because the data doesn't reach the CPU. It has to stop crunching all this data on here until it starts to do this one here. Now, when it gets to the cores, you might notice that recently Intel has launched something called a P core and an E core. What on earth does that mean? Why do we have to add more letters? What do these mean? P cores are basically big performance cores, where E cores are small efficiency cores, and that's what they stand for. B cores are the ones that go very fast, and they're very powerful. They consume a lot of power, and the E cores are more like efficient, and we call them background tasks as well. But don't underestimate the E cores, which a lot of people do, and they say that the E cores aren't real cores. There is a very good task what the E cores can do that really changes the workflow, how you work. You want the P cores to handle the task that you're currently on and working. So whether that is gaming, video editing, browsing on the web, editing photos, crunching some data, coding, you want the P cores to handle your current task, because then your PC feels the most snappy and the fastest. But there is a lot of other tasks in your PC that need to be done. Your Windows Defender, antivirus, you've got your music playing in the background, you're browsing the web at the same time while recording, while gaming, while having Photoshop and video editing at the same time open, and video rendering. How do we do all these things? Well, that's where P cores and E cores actually come in very handy. Intel is so far the only one that has P cores and E cores. Apple has as well, but we'll just focus on the Windows side right now. AMD only has P cores right now, which means that if you need to spread the task what you do on your PC, you just give it to another big P core that's going to take a lot of power. Now, what Intel has done and how the P core and E cores work is that the P cores get scheduled the one that you're working on at the moment, and E cores take the background tasks and the side tasks that don't need actively working on but still need to get done. The best example how this works is for video editing. Let's say you're video editing right now in Premiere Pro, and that's what the P cores are doing right here. You're doing video editing and you're just putting together your latest movie, absolutely amazing. But at the same time, what's happening is you're rendering proxies in the background in Media Encoder, what the efficiency cores can do. Or you're exporting another video at the same time in Media Encoder, what you just finished, but you want to start editing the next video. Then what happens is that the media encoders take that video and start working on it in the background, while the P cores that are fast will allow you to still edit the video in Premiere Pro while you don't feel any performance loss, which feels like magic, and that's where this is amazing. Now, this scheduling can happen a lot in different parts of the computer. Whatever needs to be done in the background, the E-cores can take over that load, and the P-cores will still make it efficient for you to just work. Why is a P-core an E-core? Why don't we just add more P-cores? Because the E-cores actually take less energy to consume than the P-cores, meaning that we can save on power, we can save on heat, which is always good in a computer and makes it last longer and run faster. And believe me, these E-cores are very, very powerful, and as powerful as some of the P-cores from a few generations ago. So they're not just any little nibblies that are in the background. They're very, very powerful. It's important that also you know that this here is called hyper-threading. Multiple threads per core means hyper-threading, which means we can feed more information and more tasks to the CPU and let the CPU just be ready to process the data when it's ready to do that. Now, another bit that you might see when choosing your CPU is cache, with an E in the end. That is basically a very, very, very fast temporary memory that's inside your CPU. For example, if we Google something like a 14900K ARC and we'll just click on the first link, you'll realize this is Intel's product page where we see 14900K, and we start to see all sorts of specs in here, and I'll explain most of them to you, and the other ones you can just forget because they don't mean anything to you. You'll scroll down a little bit and you realize there's something here called cache, and then total L2 cache, 32 megabytes, 36 megabytes. Well, that's not a lot, is it? That's like a little memory stick size that we had a few years ago. That's not a big amount of cache. Well, this cache is inside your CPU, and inside your CPU you have 3 different types of cache. You have L1, L2, and L3 cache. And L1 is the fastest, then L2, and then L3. The L1 is usually very, very small, as you can see in here. And this stores the fastest, most frequently used data that the CPU needs to access. Let's say you're going through a phone book and you're ringing loads of different people, and then you were like, what was the person that I just recently called, but I need to get that number again? It's going to be stored on your recently dialed memory inside your phone. That's what the CPU does as well, but in a much bigger scale with all sorts of different data that comes to the CPU from all over the place. It needs to remember all sorts of different things, and having the RAM in here is too far away and too slow to actually give it the latest, the most frequent used data in there. It goes through L1, L2, and L3, and it gets bigger as it gets the bigger number, and usually the biggest size as well. L1 is a lot smaller than L2, and then RAM is a lot bigger as well. So think of this, the more you have the cache, the better the CPU, and usually what you see is as you go from i3 to i9, your CPU starts to have more cache as well, which will make the CPU faster when processing data, especially at gaming, but it gets more and more important for creative workloads as well. Then after it has exhausted its level 1, level 2, level 3 cache, it actually stores the data in RAM and lets the RAM handle this data. Now, you might think that RAM is as fast as L3 just further away. Actually not. The L2, L2, and L1 cache inside a CPU are many times faster than RAM, can be up to 100 times faster, and that's why you can't have a lot of it because it's very expensive. Moving on, what you see here in looking at the specs for your CPU, you see lots of different numbers here called frequency, and they're all with some kind of a number and GHz next to them. What does that mean? Gigahertz, also known as frequency or clock speeds, is the speed that the CPU core operates in. So remember those CPU cores, the E cores and P cores? All of these specs on the screen represent the speed of those CPU cores. Now, what does this mean, the GHz? Hertz represents the actual interval, and if you have 1 hertz, that is 1 cycle per second. A lot of things use frequency. You've got your monitor refreshes at X amount of hertz per second, which means refresh per second. It's 60 hertz, which means 60 cycles per second, if that makes sense. Now, That G here means giga. And let me just remind you how this works. If you know kilo means 1000, after kilo we have a mega, which is 1 million. After mega we have giga, which is 1 trillion operations per second, refreshment cycles per second. Now, what you can see here, this 14900K, the max turbo frequency, what you can see here is 6 gigahertz. So 6 gigahertz means it's 6 trillion operations or crunches per second, which is super, super fast. And the faster the gigahertz, the faster amount of data it can actually process within 1 second. That's also referenced as single core performance. Often when you see these clock speeds, that doesn't mean that all of these cores can run that speed. What that means is that some of these cores, usually what you see is, let's say a core 2 here has a very good silicon lottery, and that core can run the fastest, so that can go up to 6 gigahertz, for example. That doesn't mean that all of the 6 or 8 or 24 cores can run 6 gigahertz. And that's why you can see all of these specs, all of these different gigahertzes there. Goes from all the way 2.4 gigahertz to 6 gigahertz. That's almost 3 times the cycles. And that's because different cores can go different speeds at different times, and whether you go in single core, which means only one core does something. Let's say you're editing photo and you're working with some of the faders and the photo gets adjusted, that is a single core performance, and you're not doing anything else, then that's how fast the one core can process that data and work on that photo. But let's say you're rendering a 3D project, that's where a lot of these cores can work together to put that picture together, to look at all of this data and the pixels on the work. And then when everybody starts working together, because everybody's working, they can't quite go as fast as 6 gigahertz. And that's why you have something called a multi-core performance. When you compare 2 separate CPUs, sometimes one is better at single core, but sometimes the other is better at multi-core. So single and multi-core, depending on your workflow, one might be more important than the other. For example, if you're doing a lot of rendering, the multi-core performance is a lot more important to you than the single-core performance. Perhaps you're building a PC for something that renders or render farms, that's where multi-core is more important. But if you're working actively on photos or video and editing stuff, then single core performance is perhaps more important to you. Or even working with viewport in your 3D editing applications, or working on architecture and moving around models, that is still single core performance because you're not working to put that data together. And when you see some of these benchmarks online, you see different numbers for single core and multi-core performance. Very famous ones too that you might have seen out there is Geekbench and Cinebench. They both test the CPU in single core and multi-core performance. They want to see how fast is the CPU per core, find the fastest core and test how fast can it do one single task, and also test all the cores inside your CPU and see how fast can they process things together. Multi-core and single core performance. It can also be slotted into multi-thread and single thread performance. It means the same thing. So when you hear the term of slightly threaded or heavy threaded workloads, it just means that the slightly threaded workloads are the ones where only a few fast cores can be able to do that, because we have only single tasks on the conveyor belt that we have to chew through. We can't feed multiple cores in the conveyor belt with data. And then we have multi-core performance, which means, or heavy threaded workloads, which means that we're feeding the cores a lot of conveyor belts, feed data for the CPUs to crunch through and then figure out what to do with it or put the data together. Next, what you see on the CPU specs here is memory specifications. Why is that important and how does that affect the CPU performance? What's going on in here? You can see the max memory that it supports. So the more mainstream CPUs like the i5s and i9s often don't support as much memory as the big Xeon CPUs, whether it's Ryzen or Intel, because the big Xeons and Threadripper is what you have on AMD. They are meant for big workstations and big servers that need a lot of RAM, whether you're doing some scientific calculations or simulations that require insane amounts of RAM that you and me, perhaps for just video or photo editing and our simple gaming workloads, we don't actually need that. The memory is also referenced as RAM, which means random access memory. That's where the CPU stores temporary data that you're working with. The more programs, the more things you have open at the same time, or more demanding programs, the more RAM it needs. For example, a simple web page and working on your emails doesn't require as much RAM as working with video editing. When you have big assets, a lot of things that temporarily we need to store in RAM. Now, you can see on there that we have memory types, DDR4 and DDR5. Intel's 12, 13 and 14th gen are a little bit exemption in this regard because they support also DDR4 and DDR5. DDR4, the number in the end here means the generation, and the higher the number, the faster it goes. DDR started from DDR, DDR2, DDR3, DDR4, DDR5 that we are on now, and some of the GPUs and some of the other ones actually use DDR6 and DDR7 now very soon as well. It just means that the RAM can run even faster. The faster the RAM runs, the faster it can supply the data to the CPU for the random stuff that it needs to store in the RAM slots in there. And when looking at the RAM type, it basically tells you what RAM it supports and how fast. Another thing here you can see is 5600 MTS. What is MTS? Because some of the RAM kits will actually say MHS, which means megahertz. Remember gigahertz? Megahertz? Now it's mega transfers per second. Transfers per second is another way of saying megahertz if we want to keep it very, very simple. And mega transfers per second will show you how fast the RAM can run at the CPU specs. So let's take this CPU here, 14600K or 14900K. It tells us that DDR5 can run up to 5600 megatransfers per second. That means that if you get a memory at 5600 megahertz or megatransfers per second, you slot it into your memory slots there, the CPU will run it 100% chance that it's going to run it at that speed because that's tested, that's rated speed. Think of this as a memory guaranteed speed that it will run. But perhaps you have something like this. This is a Corsair dominated titanium and this runs 8000 megahertz or megatransfers per second. That means that your CPU spec there says 5600 megatransfers per second. It says that look, this 8000 is over the spec what we promised to keep you, so you might not be able to run it. Can the CPU run it higher than 5600 megatransfers per second? Most likely. There's a lot of 6000, 64, 6800 megatransfers RAM kits that will easily run on the 14900K. This spec will basically mean that we don't guarantee that it will run because our memory controller, integrated memory controller, IMC, is rated at 5600 megatransfers per second. Memory type, and as you can see, the memory speed there. And that's for dual channel. As you can see here, max memory channels is 2. But you might be confused because all the motherboards that you're looking at have 4 slots in there. Well, that's because the CPU divides the memory channels to 2, which basically means that you still have 2 hands, but now you have to carry 4 pieces of luggage, not just 2. If you have 2, it's very easy to run that. When you have 4, you might have to lower the speed that the CPU supports just because when you're splitting memory channels, you're not able to run the data or the random access DIMM sticks, the data that you're carrying in your luggage, as fast as with 2 sticks. And that's why having the memory type and memory channels is very important to you when choosing the CPU, because that will help you choose the other components like RAM for your PC. Now, 3 more tips what I'd like to show you what is very important to check when checking the CPU. Perhaps you don't know what is the latest generation, then this supplemental information is very important to you. You can see whether this CPU is launched, if this is maybe end of life, and when was the launch date. As you can see, Q4 2023, right now it's Q1 2024. That means the end of 2023, this CPU was launched, which means that the CPU is not very old, meaning most likely this is the latest CPUs. Sometimes worth checking out the launch date, just because as the naming SKUs get higher and higher, you might be looking at a CPU that looks like a latest generation, but actually was launched quite a while ago, or some of the naming start to overlap each other. So don't get confused. Having this launch date will always show you when and how old the CPU actually is. Another very important spec, what you can see on a CPU spec list, is the base power and maximum turbo power, which here is rated as 125W and 253W. That W means watts. And watt is the energy consumption measurement, which tells you how much energy or electricity it actually pulls from the socket when it's running. The base power 125 watts and maximum 253 watt Intel specs. Basically, the higher the number, the more electricity it consumes, and the better cooler you have to cool the processor down, which is very directly linked to the higher speed. The more power it pulls, often the better the multi-core performance, the more work it can do because it pulls more power. And the very last thing I'd like to show you is when we go further down here, expansion options. We've gone through memory support and GPU specifications. That's the iGPU inside your CPU. Remember, Ks, the non-F variants, which all these stats don't mean a thing, really. We don't need to know that. But expansion options, that's something that is important or could be important to you. Maximum PCIe lanes here. As you can see, this says 20. And I've got a whole nother video explaining what do PCIe expansions and PCIe lanes mean and do. But basically it's expansion. I'm going to leave a video for you in the description below, as you can see, or you can find it in the channel. It basically means all the extra bits in your PC, whether it's your graphics cards, your SSDs, your hard drives, all your other data. The more PCIe lanes you have, the more expansion you have. If you want to add networking cards or more Thunderbolt cards, capture cards, you need more PCIe lanes to connect to your CPU. The more you have them, the better it is. The higher the generation, Gen 4, Gen 5, Gen 6, the better it is. Go check out the PCIe lanes and that will explain more about that. But essentially, this now is your CPU. And if you've never understood what CPU means and how this works, especially on the Intel platform, then this is the one. Let's have a little recap. Your namings of your CPU, very important to understand when looking at different processor names. What do they mean? And it gives a lot of information what the CPU can do and what it has and what it doesn't have. Then we have Core Ultra and laptop CPUs. What do these mean? And different laptop CPUs, that can be even more confusing. And I understand it is a lot more confusing because there's more letters. But here you can understand as you're going up and what the different letters mean, how much power it consumes and how power efficient it is and how good of the battery life this is that you can expect. Then we have our CPU cores explaining what the P and E cores mean, hyper-threading, and what does this mean doing these at the same time, or whether you need single or multi-threaded workloads. Then we have CPU cache as well as RAM support as well as the CPU speed measured in gigahertz. The faster it is, the faster the CPU runs. Hopefully this explained to you what a CPU is and helps you to choose and understand what CPUs are there, and when you're comparing different CPU models there, now even understanding more tech reviews on YouTube, perhaps on my channel or some of the others. What do they mean? What are they talking about? Now, if you did enjoy this video, I highly recommend hitting that like button. It does make a difference. And subscribe if you haven't already, because there's a lot more content like this coming out. Also, let me know if you want me to do the same for AMD or some other parts or other specifications about the PC. Now, if you do want to build yourself the best bang for buck, create a PC or just a very nice PC for different budgets, I've left my favorite build guides in the description below. I'll explain and show you everything what you need to know in there, how to build, how much to spend, what not to spend on, and you can just follow the videos and then build the best PC for you. If you do have any specific questions for me, you can reach out on MINNECT. I'll get back to 100% of any of the messages or video calls reached out on MINNECT. Thanks very much guys for watching, and I'll see you next time. Bye bye.